Okay, we are starting chapter 2 using integers and rational numbers. Now, a whole number, those are numbers like 0, 1, 2, 3, so on and so on. Obviously not going to be fractions or decimals. And integers are like whole numbers, only they can also be negative. Zero is neither a positive nor a negative integer, and positive integers are going in the right direction. And negative is going in the left direction. Okay, now we're going to graph and compare a couple of integers to one another. Graphing just means finding it on the number line, so -3 and -4. Because -3 is farther to the right, -3 is greater. A rational number is a number, a over b, where a and b are integers, and b cannot be equal to 0. So fractions and decimals are all rational numbers. Okay, now we're going to graph these numbers on a number line and tell which is greater. 4 is obviously greater than 0, and -1 is greater than -6. Okay, a decimal, there are two different kinds of decimals, either terminating decimals and repeating decimals. So terminating, if we do 3 divided by 4, 0.75, it's a terminating decimal because the decimal stops. A repeating decimal is like 1/3, which turns into 0.33, and that 3 goes on forever. That's a repeating decimal because the decimal goes on forever, actually. Okay, so now we're going to classify a bunch of numbers and tell whether they are whole numbers, integers, or rational numbers. Starting with 5. Is 5 a whole number? Yes, it is. Is it then an integer? Yes. Is it rational? Yes. Now, you won't be able to tell right away that a whole number, or like a 5 is a rational number, but it can be written as 5 over 1, so you know that it is. 0.6. Is it a whole number? No. Is it an integer? No. Is it a rational number? Yes, it is. It can be written as 6 over 10. Next number, -2 and 2/3. Is it whole? No. Is it an integer? No. Is it rational? Yes. And the last one, -24. Is it whole? No, because remember, whole numbers are 0 and on, but it is an integer. Therefore, it is rational. There are very few irrational numbers. As you can tell, all of our examples were rational. Okay, we're going to put some numbers in order. We have star's color index. It's a measure of the temperature of a star. The greater the color index, the cooler the star. Order the stars in the table from hottest to coolest. Okay, so if you need to make a number line to help you, you certainly can, but we're just going to do this by knowledge. Don't need to use a number line. The smallest one of these is Shala. The next smallest is Regal. Denebola is the next. And Arneb is the last. So Arneb is the coolest star. actually just going to do one of these. We're going to pick C. Okay, so is 3.6 a whole number? We're just trying to determine what each one of these numbers is. 3.6 is not a whole number, nor is it an integer, but it is a rational number. Same thing with negative 1.5. It's not a whole number, it's not an integer, but it is rational. Same thing with negative 0.31, and same thing with negative 2.8. Then order the numbers from least to greatest. Our smallest number is negative 2.8. Next is negative 1.5, negative 0.31, and 3.6. Okay, we are now going to talk about opposites. Now, opposites are the same number from 0. Same distance from 0 on a number line. You don't always have to use a number line, but that's helpful if you have trouble finding the opposites. So for example, 4 is 1, 2, 3, 4 units away from 0. So if we want to find its opposite, we would need to go 4 units in the other direction. And it's negative 4. So if A is negative 2.5, what is its opposite? I just need to go in the opposite direction of 0. So it'll be positive 2.5. And B would be negative 3/4. Absolute value is the distance of a number A and 0. So distance between those two. So the absolute value of these numbers. That means that even though A here is negative 2/3, the absolute value of A is the distance from 0, so it's going to be positive 2/3. And this one is 3.2. Note, the absolute value of a number is always going to be greater than 0. And we are done with section 2.1.